Hi guys, and welcome to this video, which is all for the 2019 Further Maths Paper 2 over here in Australia for VCAR. Okay, so I've already done paper 1 and there was an updated video for those 3 questions that tricked me, and yes, maths is a big fat trick, and did I get suckered in? So thank you very much to everyone out there who all left comments and said, hey, I think the answers is this. Greatly appreciated. Obviously do my best to make sure these solutions are accurate, but every now and again I get tricked. So what is, if you're watching this on YouTube, thank you very much. Do me a favor, in the corner is that little doohickey. I have a very, very small YouTube channel, and your help in making it a little bit bigger would be greatly appreciated. So click like, subscribe, thank you so very much. And if not, you're watching this on mathsguru.com. Awesome. Those of you who don't know, I have my own YouTube channel and my own website as well, where everything is searchable and life is much, much easier. Okay, you're not here to listen to this blurb. You're here to listen to the solutions. So let's kick in. Now, as I say, I'm going to do my best to give the correct answers. If I make any mistakes, then leave a comment below and I'll do what I can to upload a corrected version, or at least corrected version of these questions. Okay, so question number 1 gave a table with day number and minimum temperature in degrees Celsius for 15 consecutive days in May 2017, and there was our table. Which of the 2 variables in this data set is an ordered variable? Well, an ordered variable is for categorical data, and minimum temperature seems to be numerical, and in which case I would suggest that day number is in fact my ordinal variable. Yes, well, then they've got numbers. We don't actually have day 1, day 2. We give them dates. So in this situation, I'm going to write day number as my correct answer. So there we go, day and number. Went on to go and say the incomplete ordered stem plot below has been constructed using data from the tables for days 1 to 10. Now, it's always important with these questions to note that the key tells you how to display this number, and there were 15 numbers. Part B, complete the stem plot above by adding the numbers or the values from days 15 or 11 to 15. Okay, so scrolling those pieces of information on, what can we see here? Well, they only wanted to do days 11 to 15, so we want 1, 2, 3, 4, 5 data items. So 7.5 is going to go here with a 5. 8.0, that's the one that I think is going to trick people, because that's an 8 with a 0 there. 8.6 would put me a 6 there. 9.8 would give me an 8 there, and 7.7 would put me a 7 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data items. And there we go. That's the mark. The ordered stem plot below shows the maximum temperature in degrees Celsius for the same 15 days. Thank you very much. Use this stem plot to determine the value of the first quartile. So I'm going to swoop in a little bit. Now what I notice is we've got 15 data items. And to find my lowest quartile, or my lowest quartile, or my first quartile, then I'm going to do is find the median. All right, so the median, there's 15 data items. So let's see where we do n plus 1 divided by 2 tells me that the median value, that middle value, will be the 8th data item. 1, 2, 3, 4, 5, 6, 7. And there is my 8th data item. Now, how's that helpful? Well, that's effectively halfway through. And a quartile is half of half. So what I'm going to do now is say, well, I've got 1, 2, 3, 4, 5, 6, 7 data items there. Add 1 gives me 8, divide by 2 gives me 4. So I want the 4th number, 1, 2, 3, and 4. And I don't really need to go any further, because as far as I'm concerned, my value of my first quartile is 12.2. Now remember, it's 12.2, not 122. He goes on to say the percentage of days with a maximum temperature higher than 15.3 degrees. Well, that's higher than 15.3, that's higher than 15.3, as is that. So there are 3 days. Out of how many days in total? There were 15. And when I want to times that by 100 to give me a percentage, gives me the wonderful value of 20%. Question number 2, parallel box plots below show the maximum daily temperature and minimum daily temperature in degrees Celsius for 30 days in November. I've got a feeling that 30 days is going to come up and be important for the information in the box plots to complete the following sentences. So, squeezing it down a bit so that we can fit that on, and my boxes, what do we say? The interquartile range for the minimum daily temperature was, so first things first, it says minimum daily temperature. Let's make sure we use the minimum daily temperature. And the interquartile range is given by the upper quartile minus the lower quartile. Well, the upper quartile happens to be this line here, which is at 17. My lower quartile is at this value here, which is 12. And when I subtract the 2 together, I get my answer of 5 degrees Celsius. So there we go, 5 in there. the median value for the maximum daily temperature was higher than the median value for the minimum. So now we want the median. So here is my median line there, and there is my median line there. So let's read off those values. That was 25. And this value here seems to be 15. And I don't need a calculator to tell me that 25 minus 15 gives me 10. Now, I'm going to be honest with you, this third part got through my head, was a little bit exploded, and I have to say, if you think this is incorrect, then help me out. The number of days on which the maximum daily temperature, so this is the maximum daily temperature, was less than the median value for the minimum daily temperature. Well, here is the median, right? We already know that, so I'm going to draw that line up. And what it's saying is how many days were there where the temperature on the top graph was less than where that line is. Now this point here is an outlier. It stands for one data item. And so as far as I'm concerned, there is 1 day. Now you're going to try to say, what was that all about? Don't worry about it, long story. Part B, the temperature difference between, let's scroll up first. The temperature difference between the minimum daily temperature and the maximum daily temperature in November 2017 at this location is approximately normally distributed. Here we go, there's my normal distribution. Always like to draw those things. And what do we have? We have the mean of 9.4 degrees, and he says writing 19, 9.4 degrees with a standard deviation of 3.2 degrees. Determine the number of days in November for which this temperature difference is expected to be greater than 9.4. So it's looking for that. Well, how are you going to do this? Well, what do I know about the percentages in this thing? Well, I know that that percentage is 50% of my data. And it says determine the number of days in November. Previously, it told me that there were 30 days in November, and I'm looking for 50% of them, which hopefully gives me 15 days. Question number 3. The 5-number summary for a distribution of minimum daily temperatures for the months of February, May and July in 2017 is shown in the table 2. The associated box plots are shown below in the table. Let's squidge this up a little bit so we get some room. Explain why the information given above supports the contention that minimum daily temperature is associated with the month, and refer to the values of an appropriate statistic, singular, in your response. I have to say, this is the one thing about the Further Maths course that I don't particularly enjoy, because this is the waffly stuff, the bit that you're like, okay, are you sure? So what I'm going to do is I'm going to write what my response I think would be, and then obviously if you think that you have a better response, please, please, please leave it in the comments below. If you think that I've missed the point, leave it in the comments below. Let me be polite, be kind. Okay, so this was my suggestion. The data shows that as the month has increased, the median minimum daily temperatures decrease from 10.9 degrees in February through 7.5 in March to 5 degrees in July. Hence, minimum daily temperature is associated with month. I'm sure there are many things. I'm not affiliated with VCAR. I have no idea what they're actually looking for as an answer. As I say, if you've got a better idea, put it below. Question number 4 goes on to say the relative humidity percent at 9 AM and 3 PM on 14 days in November 2017 is shown in table 3 below. And there we have a table, 9 AM and 3 PM. Let's squidge it up a bit. A least squares regression line, or a least squares line is to be fitted to the data with the aim of predicting the relative, there we go, now there's that word, that's predicting the relative humidity at 3 PM from the relative humidity at 9 AM. Name the explanatory variable. Well, I always remember explanatory is on the x-axis, all right, so the explanatory, and what we do is we predict these values on the vertical from my explanatory. So as far as I'm concerned, if we have this here, that this is going to be my humidity at 9 AM, and this is going to be my humidity at 3 PM. And so name the explanatory variable. As far as I'm concerned, it would be humidity at 9 AM. So let's scroll that up a little bit. Humidity at 9 AM. Okay, determine the values of the intercept and the slope of this least regressions line. Now that meant putting all of the data into your calculator. Okay, so loading up my CAS calculator, and as you'll probably see, I've got some stuff here already. I'm going to go to menu, and then I'm going to go across, and nope, I'm not doing financial yet. Oh, come on. I am doing statistics. All right, and there is my data already preloaded. And again, it's always a good idea to make sure that you check that actually all of that data is correct. How am I now going to find my least squares regression line, or my intercept and slope? I'm going to go calc, regression, linear regression. I'm going to say list 1 is main x, list 2 is main y. Hit OK, and out comes the values of A, where there is your intercept is minus 1.26178, and my gradient of 0.76. And it's important to note that the question here said that it wanted your answers rounded to 3 significant figures. So, as far as I'm concerned, that gave me minus 1.26 there, and my gradient of 0.76 and 5 there. That's my 3 significant figures. And it says determine the value of the correlation coefficient for this data set. Well, I don't need to determine it because actually I can just read it off my calculator. And again, it wants my value to 3 decimal places. If I bring it up, my R value there was 0.87 and 1. So 0.871. The scatter plot below shows the atmospheric... I'm having real trouble speaking today. The scatter plot below shows the atmospheric pressure in hectopascals, HPA, at 3 p.m. Pressure 3 p.m. Plotted against the atmospheric pressure in hectopascals at 9 a.m. Pressure 9 a.m. For 23 days in November 2017, a particular weather station. A least squares regression line. I keep saying that. All right, a least squares line has been fitted to the scatter plot as shown, and the equation of this line is given as such. All right, there we go. So we have our line as such. Interpret the slope of this least squares line in terms of the atmospheric pressure at this weather station at 9 a.m. and at 3 p.m. I love these questions. So I'm going to zoom in a little bit, and what I'm going to do is I'm going to write my answer, and I will fade straight back in. And here we go. So for every 1 hectopascal increase in pressure at 9 a.m., there is a 0.8894 increase in pressure at 3 p.m. All right, so that's very much the gradient. For every 1 I'm going across at 9 a.m., I'm going up 0.8894 for 3 p.m. Use the equation of the least squares line to predict the atmospheric pressure at 3 p.m. when the atmospheric pressure at 9 a.m. is 1025. That's just asking you to put into the equation above. So I'm going to do 111.4 plus 0.8894 multiplied by 1025, and it wants our answer rounded to the nearest whole number, and I'm going to tell you how that just becomes 1023 HPA. All right, so 1023 is a prediction made in part B, an example of an extrapolation or an interpolation. Well, an extrapolation is where we're taking a data item outside of the range of the values that we had. So if we have a look here, we were looking for 1025, and as it turns out, that is well and truly within the data that I had, and so it is an interpolation. It goes on to say, determine the residual when the atmospheric pressure at 9 a.m. is 1013. Obviously, to find the residual, what do we want? So we know the residual is equal to the actual value minus our predicted value. So our actual value, we're going to read off 1013. So where is 1013? So here is the line for 1013. That is my actual value, which came out as 1015. So my actual value was 1015, and subtract from that my predicted value at 1013. So what I'm going to do is firing up my calculator 111.4, and then we're going to add on to that 0.8894 multiplied by 1013 gives me the staggering value of 1012, so 1012.3622, and then when I subtract those from one another, so let's do, what was it, 1015, and we will subtract, please, if you will, my previous answer, which I'll just drag and copy, and then I get 2.6378, and it wants it rounded to the nearest whole number, so in which case my residual would be 3. The mean and standard deviation of pressure 9 a.m. and pressure 3 p.m. for these 23 days are shown in the table below. Now, the minute I see this mean and standard deviation, which was very much the type of question we had in paper 1, I know that it's going to look for the equation of the least squares line and the information in table 4 to show that the correlation coefficient for this data is. Now, you've got to show that it is. So in this situation, I know that the slope is equal to r times s of y divided by s of x, in which case I want that r is equal to s of x times the slope divided by s of y. So putting those values in, I get 4.5477 multiplied by 0.8894, all divided by 4.1884. And when I put that all into my calculator, let's just check that actually does get what it says it's going to get. So what do we have here? 4.5477 times 0.8894, please. And will you divide that by 4.1884 and hit enter? And what comes out? 0.966 to 3 decimal places. Yep, so 0.966. And I've shown it. What percentage of the variation in pressure is explained by the variation in pressure at 9 AM around your answer to 1 decimal place? And well, the first thing it says, what percentage, and the minute I see this variation in variation, I know it's looking for the value of r squared. So taking my calculator, I had the value of r. So what I'm now going to do is I'm going to square it, and that gives me 0.9325, so 0.9325, and so it goes on. But because the question wanted a percentage, I now know that r squared would be equal to 93.3%, reminding that that's going to be rounded to 1 decimal place. The residual plot associated with the least squares regression line is shown below. The residual plot above can be used to test one of the assumptions about the nature of association between atmospheric pressure and the atmospheric pressure at 9 AM. What is this assumption? And I'm just going to write the word linearity. All right, so a residual plot helps me try and decide out whether a function has linearity. The residual plot above does not support this assumption. Explain why. Well, looking at this, it doesn't seem to be random. I could sort of see that there is a bit of a curve going on here. Remember, for it to be linear, those points have to be totally and utterly random. So I would put something along the lines of, explain why there appears to be a pattern, and hence the data would appear to not be linear. Now again, you may disagree with that answer, and again, leave comments below. I'm more than happy to sit there and think, oh, really? But when I saw this question, that was what I was thinking. Oh, we're loving this question on seasonal data. Right, the total rainfall in millimeters is given by that table, and it basically goes on and says, well, look, can you fill in the seasonal indices for summer, autumn, winter, and spring? Now, I really like the fact they give me a value here of 1.41, because that means I've got something to try, and if I can't get that with the data they've given me, then obviously I'm not really sure what I'm doing. So I know that the first thing I need to do is find the average seasonal data for 2015. Now, how do I do that? Well, when I add all these together, I actually get 640, which when I divide that by 4 gives me 160, okay? Likewise, when I do the same here, I get 600, and when I divide that by 4, I get 150. So using that information, I can now work out each of the seasonal indices for 2015 and 2016 for winter. Now, what I'm going to do is bring up my calculator and do sort of this. 222, I'm going to divide that by 160, gives me 1.3875. I'm going to do 216, and I'm going to divide that by 150. I get 1.44, and then if you remember, what you have to do then is take both of those numbers and add them together and average them. So dragging that down, let's add it to that value here, please. He says obviously not dragging it, and then divide by 2. And lo and behold, I get 1.41, so great. I actually can get all that information. Now, I'm not going to bore you with all the individual calculations. I've already shown you how to do it there. But what I ended up getting when I did this was 0.89 there, 1.0 there, or 1.00 to 2 decimal places, and 0.70 there. Okay, for part B, it says the total rainfall for each of the 4 seasons in 2017 is shown in the table below. Use the appropriate seasonal index from table 6 to deseasonalize the total rainfall for just winter. Okay, so looking at the winter, we have, he says, not highlighting at all, 262. So there's 262. And what I'm going to do is I'm going to scroll up and divide that by my value of 1.41. And doing that on my calculator gave me, to the nearest whole number, 186. Phil is a builder who's purchased a large set of tools, and the value of Phil's tools is depreciated using the reducing balance method. Thank you very much. The value of the tools in dollars after n years can be modeled by the recurrence relation shown below. So use the recursion to show the value of the tool after 2 years is. All right, so we're using that recursion. So we know that V0 is 60,000. So we know that V1 is going to be 0.9 times 60,000, which I can bring up on my calculator. And what do we say? So 0.9 times 60, 1, 2, 3, gives me 54,000. And V2 then would be 0.9 multiplied by 54,000, which when I again type that into my calculator, so let's do times 0.9 because we've got a previous answer there, was in fact $48,600. There we go. Because it showed that, you have to show you're working. What is the annual percentage rate of depreciation used by Phil? We know our multiplier was 0.9, and that means that it is depreciating by 10%. Fingers crossed you should be able to just have looked at that question and known the answer. Phil plans to replace these tools when their value first falls below $20,000. After how many years will Phil replace these tools? So 60, 1, 2, 3, using my calculator, times by 0.9. Oop. Go back and we say, if you will please, answer times 0.9 says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So there we go, 11 years. Just a matter of hitting execute on my calculator. So how many years? The answer is 11. Phil has another option for depreciation. He depreciates the value of the tools by a flat rate of 8% of the purchase price per annum. Okay, that works for me. So now we've got to write a recurrence relation. Well, I know that V0 stays at 60,000. I know that V of n plus 1 is equal to V of m minus, and what we need to do is work out 8% of our original price. So 8 divided by 100 and times that by 60. Why is this not doing times, please, by 60, 1, 2, 3, and that gives me $4,800. So each year, that's going to reduce by $4,800. Phil invests $20,000 in an annuity from which he receives a regular monthly payment. The balance of the annuity in dollars after n months, an can be modeled by the recurrence relation given by that. What monthly payment does Phil receive? Well, an annuity has a regular payment taken out of it every single month or compounding period or whatever. And there we go, just reading off this formula gives me $3,700. Show that the annual percentage compound interest rate for this annuity is 4.2%. Well, we know that this multiplier here, this 1.0035, is my rate of interest, or it's the multiplier. So I know that if I do 0.0035, which is per month, and I times that by 100 to give me a percentage, and times that by 12, I'm going to get, well, let's just check, 0.0035 times 100 and times by 12, if you would, gives me 4.2%. Again, you'd be expected to show that working out. At some point in the future, the annuity will have a balance that is lower than the monthly payment amount. What is the balance of the annuity when it first falls below the monthly payment amount? Round your answer to the nearest cent. And so what I did was I said, well, I don't know how many periods it's going to be because it wants to know how many, but I do know my interest rate was 4.2%. I knew my principal value because that's what he invested, so he gave the bank 200,000, which is a negative. His payments, well, payments were coming out, or they were giving him, how much was it, 3,700. And what I'm going to say is I'm going to look at where my future value now actually is 3,700. My payments were 12, my monthly payments were 12, and it was compounding monthly. Yep, so there we go, monthly. And so what I did was I loaded up that N gave me 59.02 months. So if I now change this and say, well, okay, how much would I have had left in my account after 59 months, and say my future value, that gave me $3,778. And so what I'm now going to do is say, well, what have I got after 60 months by hitting the same future value, which gave me $92.15. There are undoubtedly many ways of doing this question, but basically we know that he's getting an interest rate of 0.0035, 1.0035 per month. And so I'm going to multiply that by his $200,000 investment. And that's actually going to give me how much he's getting in terms of his interest. So bring up my calculator, 1.0035 times 200, 123. Hit enter, gives me $200,070. Oh my goodness, $200,700, which means he's actually going to end up with $700 interest per month. Well, if I don't want to be gaining any more money, then I know that therefore he's going to get $700 per month to make this a perpetuity. Phil would like to purchase a block of land. He's going to borrow $350,000 to make this purchase. Interest on the loan will be charged at 4.9% per annum, compounding fortnightly. Love, love, love. After 3 years of equal fortnightly payments, the balance of Phil's loan will be that much. What is the value of each fortnightly repayment he is going to make? Well, let's bring up my financial solver, if you would be so kind, and let's fill in the information. All right, 3 years of fortnightly payments. So he's doing 3 lots of 26 payments because there's 26 fortnights in a year. His interest rate is 4.9%. He has borrowed $350,123, which is positive. His payment, that's what we're trying to find out. His future value is going to be what he owes, which is minus 262,332.33, and it is 26 and 26. So when I hit payment, out comes the spectacular value of $1,704.03. What does it say? It wants it to the nearest cent, so $1,704. $1,704.03 is his fortnightly repayment. Now, what is the total interest Phil would have paid over these 3 years? Well, first thing, let's work out how much he's paid. So he's done 3 years, 26 payments each of those years, and he's paid in $1,704.03, or that's what he's paid back. So bring it up, let's go to main. 3 times 26 times 1704.03 gives me $132,914.34. But how much has he actually paid off of his loan? Well, he took out $350,000. He still owes $262,332.33. So if we again bring up my calculator, then I can say that minus 262,332.33 gives me that he still owes, or he's only paid off $87,667.67. So if I subtract those two, then what I will get is my interest payment. So we do this, if you will, minus this, and hit enter, and we get $45,200, and that's a lot of money. $45,246.67 to the nearest cent. And over the next 4 years of his loan, Phil will make monthly repayments of that much and will be charged interest at a rate of that much, compounding monthly. Let N be the balance for the loan n months after these charges. Write down a recurrence relationship. Well, we know that B0 is going to be given by 262,332.33. There's actually been a change of conditions. They've moved on now. They've said over the next 4 years. And they've not gone back and changed the question. They've said over the next 4 years. So we know that B of n plus 1 is equal to, now what does it say? We've got 4.8% per annum compounding monthly, and what it wants to do is let the balance of the loan n months after the charge. Write down a recurrence relation in terms of that could be used to model the balance. What are we saying? It's compounding monthly. Okay, so because it's compounding monthly, we need to make sure that we work out our interest rate monthly as well. Okay, so firing up my calculator, I've got an interest rate of 4.8%. I'm going to divide that by 12 and divide that by 100. That's going to give me a 4e minus 3, which is just 0.004. So I know my multiplier now is 1.004. I'm going to multiply that by the previous month's value, and then I'm going to subtract from that 3,517.28. And there we go, there's my 2 marks. There we go, financial. Now we're going to move on to the modules. All of the modules will be here, but I'm going to go through them in order. If this isn't a module you're actually interested in, fast forward. You can see from the doohickey below me, might be over there, I don't know, that actually which module I'm dealing with. So matrices. The car park at the theme park has 3 areas, A, B, and C. The number of empty and full parking spaces in each of the 3 areas at 1 p.m. on a Friday are shown in matrix Q below. What is the order of matrix Q? Sorry about that if that picked up on my microphone. The order of matrix Q, well, remember we do rows and columns. There are 3 rows. So 3 by 2. Write down a calculation to show that 110 parking spaces are full at 1 p.m. Well, there we go. It's basically just asking us to add those values together. So 50 plus 20 plus 40 is equal to 110. Drivers must pay a parking fee for each hour of parking. Matrix P below shows the hourly fee in dollars for a car parked at each of the 3 areas. The total parking fee in dollars collected from these 110 parked cars, if they're parked for 1 hour, is calculated as follows, where matrix L is a 3 by 1 matrix. Well, basically, if we're doing the 110 cars parked, then I'm looking for this column here, this 50, 20, 40. And so what it's actually asking me to do is say that L is equal to 50, 20, and 40, and hopefully your matrix bracket will look, 50, what happened there? 50, 20, 40, well hopefully your matrix brackets look better than mine. The number of whole hours that each of the 10 cars have been parked was recorded at 1 p.m. Matrix R below shows the number of cars parked for 1, 2, 3, and 4 hours in each of the areas A, B, and C. Matrix RT is the transpose of matrix R. Complete the matrix RT. When you transpose, your rows become columns and your columns become rows. So we get 3, 1, 1. We get 6, 10, 3. We get 22, 7, 10. And we get 19, 2, and 26. Explain what the element in row 3, column 2 of matrix RT represents. Well, whereas before this was A, B, C, and this was 1, 2, 3, 4. What it's saying is, well, what does it say? Row 3 and column 2 is this value here. So as far as I'm concerned, and I'm hoping I've not been tricked here, it seems a bit of a silly question really, but what it's saying is that 3 cars were parked in area A, in area C for 2 hours at 1 p.m. Question number 2, the theme park has 4 locations: Air World, Food World, Ground World, and Water World. Number of visitors at each of the 4 locations is counted every hour. And by 10 a.m. on Saturday, the park has reached its capacity of 2,000 visitors. Now I know, because I've done the question, that that's going to become quite useful in a moment and can take no more visitors. The park stayed at capacity until the end of the day. So the state matrix S0 below shows the number of visitors at each location at 10 a.m. on Saturday. What percentage of the park visitors were at Water World at 10 a.m. on Saturday? Well, what was it? Park were at Water World, so that's that one there, that's the 400. And as I say, we now know we got 400 out of a total number of 2,000. And we're going to multiply that by 100, which gives me the grand value of 20%. Let Sn be the state matrix that shows the number of visitors expected at each location n hours after 10 a.m. on Saturday. The number of visitors expected at each location can be determined by the matrix recurrence relation below. Complete the state matrix S1 below to show the number of visitors expected at each location at 11 a.m. on Saturday. All I needed to do was put this matrix in and multiply it by that matrix there, and I'm not going to do that because my calculator is running out of battery. But what I ended up with was 300. 780 and 620. So that was my state matrix S1. Now it says, of the 300 visitors expected at Ground World at 11 a.m, what percentage were either at Air World or Food World? Now again, it's back to this percentage. This exam loved percentages. Now, where do we get this information from? Where do we get this S1 from? Well, what I ended up doing was saying, well, I knew that came from 0.1 times 600 plus 0.2 times 600 plus 0.2 times 400 plus 0.1 times 400. Now, where does that come from? This was my A, my F, my G, and my W. That was just basically from taking my transition matrix and multiplying it by my first value. Okay, so what I was doing was, yes, looking at that. So Ground World, what percentage were they either at Air World or Food World? So I looked at this value here and this value here, and when I added those together, or when I did those calculations, I got that as 60, that was 120, that was 80, and that was 40. And so, because I wanted to know who was at A and F, I added those two together, which gave me 180. But once again, it needed to be a percentage, which was out of the 300 people that were actually there. And so what we ended up with was 180 divided by that gave me 60%. The proportion of visitors moving from one location to another each hour on Sunday is different from Saturday. Matrix V below shows the proportion of visitors moving from one location to another each hour after. Matrix V is similar to matrix T but has the first two rows of matrix T interchanged. The matrix product will then generate matrix V from matrix T is where it's a binary matrix. Write down matrix M. Now, basically, if I want to find M, I know what V is. I'm trying to find M, and I'm trying to do T. So what I've got to realize is that I can't do this in this way, all right? I'm trying to, like in algebra, what would you do? You divide both sides by T. But what I know is if I do V times the inverse of T, and M times T times the inverse of T, then what I get is V times the inverse of T is equal to M times the identity matrix, and so V times the inverse of T gave me the value of M. Now again, I'm not putting that into my calculator because it would take way too long for this particular video, but put in V, put in T, raise it to the power of -1 on your CAS, press enter, and out come this matrix 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. On Sunday, matrix V is used when calculating the expected number of visitors at each location every hour after 10 a.m. It is assumed that the park will be at its capacity of 2,000 visitors for all of Sunday. Let L0 be the state matrix that shows the number of visitors at each location. All right, there we go. So we got some information there. V times L0, where that and that, blah, blah, blah. Safety restrictions require that for all 4 locations have a maximum of 600 visitors. Which location is expected to have more than 600 visitors? Now, as it turns out, when I put the information into my calculator, what I ended up with was a matrix that had 810 people ended up in Airworld, if that's the correct language, if that was the correct one, right? So 810 people was expected, so I put here Airworld. Now again, all that required me to do was take the 2 matrices and multiply them together. Okay, let's do it. I know you want me to do it, so let's do it. Let's bring up my keyboard. Whew, this is going to take some time, so let's see if I can do this relatively quickly. Math 2, he says 1, 2. Let's make that 4 by 4, if you will. Thank you very much. I'm filling my values. 0.3. Whew, that took a long time to type, and let's do this one now. We want that one, so we're going to times it by 500. No, 500, not 50, 500. 6, oh dear me, 6, butterfingers, 600, 500, and 400, boing, boing, and there we go. Out came 810. So that A, which was Airworld, basically gave me the value that was more than 600. Now this information then became important to me. So moving on to part B, it says whenever more than 600 visitors are expected to be at a location on Sunday, the first 600 visitors can stay at that location and all others will be moved directly to ground world. Now when I did the first set of these solutions, I didn't realize ground world was the 3rd item in that matrix, and unfortunately the answer was incorrect, but we've got it right this time. State matrix Rn contains the number of visitors at each of the locations n hours after 10 a.m. on Sunday. Blah, 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 blah. Matrix R1 can be determined from the matrix recurrence relation given by here. The R1 is given by V times R0 plus B1. Now this B1 matrix actually is just really saying, well, where are we redistributing those people from? Now, as it turns out, we've already pretty much got the answer to V times R0, because if we look again, we notice that R0 is in fact this matrix here. So when I put that into my calculator, and again, I'm not bringing up my calculator for this particular question, he says furiously flicking through his own answers, gave me, what did he give me? 810. So when I did that on my calculator, I got 810, I got 300, 310 and 580. So let's put the square brackets where they need to be and make life a bit easier. Now obviously, because the question then says, well, we can't have more than 600 people, this is now an issue. So I've got to get the extra people and put them in garden world or ground world. Garden world. Anyway, ground world, which basically means they've got to go into here. Now to be able to do that, I need to have my matrix B1, which tells me that I've got to subtract 210 from there. The value there stays, I don't need to do anything because this 300 is below the quota. 310, well, we've remembered there, we're going to move the 210 people from Airworld into Ground World, and likewise there's going to be a 0 there because we don't need to affect any of those numbers. So B1 deleting that value there. So B1 gives me minus 210, 0, 210, and 0. Maybe I should draw these square brackets afterwards. It then goes on to say state matrix R2 can be determined from the new matrix rule. R2 is equal to V times R1. Okay, so we know what R1 is now because we've, going back to my values up here, I now can say that R1 becomes equal to, well, that's going to become 600. That stays as 300. Then 210 onto there gives me 520, and then 580 go on there. So that's my new R1. So what I'm going to do is multiply that by V. So I multiply that by V, and then I'm going to add some sort of B2. Now in this situation, they're not interested in this value of B2. We don't want to get tricked. They're actually interested in the final result. And that's realistically saying, well, what's going to happen after we redistribute these people? So when I put this into my calculator, when I did V times this matrix here, what I got out was 786, 288, 282, and 644. And what we notice now that we've got two values where there are too many people. So I need to get rid of 44 and put them in there. So take away 44 from there. And I need to put 186 into there as well, which I believe makes my R2 equal to 600. 288, that one doesn't change. This one becomes 512, and this one becomes 600. I have to say, Module 2 provided me the greatest of hardships. Okay, I used to think this was the easiest module, not anymore. So much respect to those of you who have done this module. To be fair, I haven't taught it for 5 years, and so some of this was absolutely messing with my head, but let's see where we go. Right, we got Fensedale High School has 6 buildings. The network below shows these buildings represented by vertices. The edges of the network represents the paths between the buildings. Which building in the school can be reached directly from all other buildings? Actually, it is the office. Thank you very much. That was a nice one. So I just wrote office and moved on. A school tour is to start and finish at the office, visiting each building only once. What is the mathematical term for this? Well, if you're actually going to go around it and visit each building only once, then it is called a Hamiltonian. Well, Hamiltonian. But in this situation, it's actually going to be a cycle. Why is it going to be a cycle? Because you've got to start and finish at the office. It's got to start and finish at the same point and visit all the other buildings. That's a Hamiltonian cycle. Draw in a possible route for the school tour on the diagram. Well, basically, what did it say? I had to start at the office. So I did this, and I came around to here. I went to the computer. I went to the library. I went to the mathematics room. I went there and basically around. Love this. I know you're going to say, well, it's not complicated. All right, I know. Chill. It gets more complicated. So, Fensedale High School offers students a choice of 4 sports: football, tennis, athletics, and basketball. The bipartite graph below illustrates the sports that each student can play. Complete the table below by allocating the appropriate sport to each student. Well, first things first, I noticed that Marco is the only person who can do athletics. So Marco has to do athletics. All right, so that now takes Marco out of tennis, so he can't do tennis and he can't do basketball. Well, by doing that now, I noticed that there's only one person now who's available to do the basketball, and that is Juan. Hopefully that has pronounced his name correctly. So there's basketball, and that takes Juan out of tennis as well, which means that there's only one less person left for tennis, which is in fact Blake. So Blake, you are going to do the tennis, which suggests that Charlie is going to do football. And there we go. That's the bipartite graph done. Ooh, love that. The school medley relay team consists of 4 students: Anna, Imani, Jordan, and Lola. The medley relay race is a combination of 4 different sprinting distances: 100, 200, 300, and 400, run in that order. And the following table shows the best time in seconds. Right. To fill this in, we have to use, what did I call this? The Hungarian algorithm. And again, way too long for this particular video. I mean, way too long for this video. Because what you have to do is for each of these rows, you take the smallest value and you take them away, take them away, take them away, and take them away for each of those rows. And what that actually ended up was giving me all zeros here. Oh, no, do that actually in a pen. So that gave me all zeros here, 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 and here. And then you, what did you do? Then you took the smallest value from each of the columns and you tried to create a 0, and that gave me a 0. But the problem was I kept going on and on. So the best way for me to solve this was actually using Microsoft Excel. And so while the values on this may not necessarily make a huge amount of sense, what hopefully you'll see is that this first table above was the original data. Then what I did was take away the value, the smallest value from each of the rows. That's the second table. The next one then was where I took away the smallest value for each of the rows, which gave me then 2 lines through my zeros. And then what did I have to do? Well, then you have to find the smallest value of the whole table, add it on to wherever it crosses, and then subtract it from all of the rest of the values. And then you notice that you got zeros in there as such. And because I ended up with 4 lines, and I'm trying to make 4 choices, that is effectively what I ended up with. Putting that back into my table, I believe that Anita then could do the 400 meters, Imani could do the 200 meters, Jordan could do the 100 meters, and Lola could do the 300 meters. Okay, so question 3, Fensdale High School is planning to renovate its gymnasium, and this project involves 12 activities A to L, and the directed network below shows the activity and their completion time in weeks, and I've already scaffolded this to pull all of my boxes because it's going to ask me how many activities are on my critical path. So I'm going to go through and I'm going to scan through my network, and I'm going to get the largest values when I go that way and the smallest values when I go that way. So filling these in, that gives me 0 there, that's 2, 6, 11, that could be 14 or it can be 15, so we're going to make it 15, that becomes 16, that becomes 20, that could be 22 or 21, so we'll leave it 22, 22 plus 7 is going to be 29, which is going to be bigger than that one, and 29 plus 6 is in fact 35, and there we go. So we now at least can code a question because it said that the minimum completion time for the project is 35 weeks. Cool. Now we're going to go backwards, and remember when we go backwards, I want the smallest values. All right, so we're going to start with 35, and then what are we going to go? We're going to go to 29 there. This is going to go backwards, it'll be 25 there, so 25, but actually we can get there in a different way. So that's we're going to 22. 20, marvellous, that's the smallest value. 20 minus 4 is 16. 22 minus 5 is bigger than 16, so that's my smallest value. That becomes 15. 15 minus 3 when I went to school was 12. 15 minus 9 gives me 6, because that's going to be smaller than 12 minus 5. That's going to give me 2, and that's going to give me 0. And so, ladies and gentlemen, there we go. I've just gone through and scanned my network. So let's highlight on here my critical path. 1, 2, 3, 4, 5, 6, 7, and 8. So look, according to this, there will be 8 activities on our critical path. So I'm going to write 8 activities. I mean, I could have written just 8, but let's do 8 activities. Determine the latest start time of activity E. Well, we just read off the value in that box. And so as it turns out, the latest start time activity E is 12 weeks. Yeah, or week 12, one of those. Which activity has the longest float time? Well, in this situation, zooming back in again, I don't particularly have to worry about anything on the critical path because I know there the float time is going to be 0. But what we can do is all the ones that aren't. So let's look at L. 29 minus 4 is 25, minus 20 gives me 5. What about H? 22 minus 5 gives me 17, minus 16 gives me 1. 15 minus 3 gives me 12. Minus 11 gives me 1. I lost what I was doing there. 12 minus 5 gives me 7. Minus 6 gives me 1. Have I done them all? I believe I have. So there we go. So looking at this, it would appear that J, activity J, has the longest float time. It is possible to reduce the completion time for activities C, D, G, H, and K by employing more workers. The completion time for each of these 5 activities can be reduced by a maximum of 2 weeks. So we can do 0, 1, or 2 weeks. What is the minimum time in weeks that a renovation project could take? So I'm just going to highlight these. So that was C, D, where are we? G, H, and K. There we go. So those are the 5 that we can reduce. And again, I'm just going to tell you the answers for this particular one. In a later video, I'm going to go back through crashing and costings and all those type of things. But at this moment in time, I don't think you want to sit through 47 minutes of me trying to work all this out, because it's a fairly long question, to be perfectly honest with you. So what I did was I took 2 off of D. To make that 7, I took 2 off of G, which made that 2. I took 1 off of H, which made that 4. And I took 2 off of K, which made that 5. Now, when we then go through all of this, what happens is this value here, I believe, reduces to 29 weeks. And I think that's the minimum it's going to be. All right, so the completion time, what is minimum time in weeks that the project could take? 29 weeks. And finally, the reduction in completion time for each of these 5 activities will incur an additional cost to the school. The table below shows the costings. Basically, it now wants to only reduce it by 4 weeks. All right, so it only wants to be reduced by 4 weeks at minimum cost. So we can't just transfer the answers over from part D, but what I can do, and again, I'll do a separate video for this whole question. I know many of you out there just want the solutions to this, and this is what I believe the solution is. So many of you suggested, or what is being suggested, is that C is reduced by no weeks. What did I then have? D is reduced by 2 weeks. I've got G is reduced by 2 weeks. H is reduced by 1 week. And K would be reduced by no weeks for this to be the most cost effective. And as I say, I'll do that in another video later on. Okay, I have to say, this module, yeesh, hard. Geometry and Measurement loved this particular module. Yes, the following diagram shows a cargo ship view from above. The shaded region illustrates the part of the deck in which shipping containers are stored. What is the area in square meters of that? Well, we did 160. We times that by 40, and we added on 12 times 25, which gives me 6,700 square meters. Each shipping container is in the shape of a rectangular prism. Let's zoom in a little. Each shipping container has a height of 2.6, it has a width of 2.4, and it has a length of 6 meters, as shown in the diagram below. What is the volume in cubic meters of one shipping container? 6 times 2.4 times 2.6 gave me the stunning value of 37.44 meters cubed. What is the total surface area in square meters of the outside of one shipping container? Well, find the area of this, find the area of that, find the area of that, and double it, or whatever way you did. So I did 2 times 6 times 2.4, right? That was 2 lots of the base, plus 2 lots of 2.4 times 2.6, which was the 2 ends, and I added that to 2 lots of 6 times 2.6, which was the front and the back, which gave me 72.48 meters squared. One shipping container is used to carry barrels. Each barrel is in the shape of a cylinder. Each barrel is 1.25 meters high, has a diameter of 0.73 meters, as shown in the diagram below. Each barrel must remain upright in the shipping container. And what is the maximum number of barrels that can fit into one shipping container? I think this is a bit of a trick. All right, so what you've got to do is you've got to realize that this was 6 meters by 2.4 meters. And you know that actually the shipping container, or that cylinder, is set 0.73 meters wide. So you're really trying to find out how many 0.73s can I get that way? How many 0.73s can I get that way? And because we've got a height, I know that the height was, what did it say? The height was 2.6. And I know that each container is 1.25, so I've got to work out how many 1.25 containers I have. So when I did that calculation, I worked out that I could get 8 going that way. I could get 3 going that way. And then I could stack them 2 high. So I did 8 times 3 times 2, which gave me 48 barrels. Now, I don't know. I think some people may have found the volume of this and then sort of did the volume of the shipping container divided by the volume of this. It's not really going to work, I don't think. I think this is what they were looking for. Question number 2, a cargo ship travels from Magadan to Sydney. Explain with reference to the information provided how we know that Sydney is closer to the equator than Magadan. Well, we know that the equator is on our great circle, okay? But the point of it is, as I say here, there's 34 degrees below the equator. That's 60 degrees above the equator. And just because 34 degrees is closer than 60 degrees as we go. So, now again, because this is one of those waffly questions, as far as I'm concerned, that would be my answer. Would that be accepted? Hopefully. If you've got different answers, don't worry about it, it's fine. Assume the radius of Earth is 6,400 kilometers. Find the shortest great circle distance between Magadan and Sydney. So I'm going to zoom out just a little bit to give myself some working. So what I know is I've got this circle, and let's imagine here is my value for, what was it, Magadan was 60 degrees, and Sydney was down here at 34 degrees. And so we've got some sort of radius, we know what the radius here, and some sort of angle. So I know that I can find that arc length by just some basic circle stuff. So to find the arc length, I'm going to do the angle divided by 360 times 2 pi r. Well, we know the total angle there is 60 plus 34, which is 94 degrees, divided by 360 times 2 times pi. Let's move it over a bit so they've got some room. 2 times pi times the radius, which was 6,400. Okay, so putting that into my calculator, what I ended up with to the nearest was 10,500 kilometers. I have to say, I quite liked part C. The cargo ship left Sydney at 6 a.m. on the 1st of June. So, okay, so here is Sydney, and it left at 6 a.m. And it gets to Perth a while ago at 10 a.m. on the 11th of June, and that 6 a.m. on what date was that? The 1st of June. And then it goes on to say there is a 2-hour time difference between, highlighter. Then it goes on to say there is a 2-hour time difference. And I suppose part of this requires you to know whether Perth is behind or ahead. And actually, as it turns out, Perth is behind Sydney. So it's 2 hours behind. So what I'm now going to say is, well, actually, although it says it's leaving Sydney at 6 a.m., I'm going to do it on Perth time and say that actually it left at 4 a.m. Perth time, because now all I need to do is work out how long it takes to get there. So it left on the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th and 11th. That was 10 days. And 4 a.m. to 6 a.m. is 6 hours. And because it wants to know how many hours it's going to be, so I did 10 times 24 plus 6, which gave me 246 hours. The following diagram shows a crane that is used to transfer shipping containers between the port and the cargo ship. The length of the boom BC is 25 meters. Let's write that on. And the length of the hoist AB is 15 meters. Let's write that on. And write a calculation to show that the length AC is 20 meters. Well, basically we know that we can use Pythagoras' theorem here. And so we know that AC squared is equal to 25 squared minus 15 squared, or that AC would be equal to the square root of 25 squared minus 15 squared, which is equal to 20. Find the angle ACB. Round your answer to the nearest degree. Okay, we can do that. So let me see, what have we got? We've got ACB, which is this angle here. ACB, we've got the opposite, and we have the hypotenuse. So we know the sine of the angle is equal to the opposite, which is 15, divided by the hypotenuse, which is 25. So I don't know what I was writing there. So theta is equal to the inverse sine of 15 on 25, which I'm going to use my calculator. So I don't know why there's a pi there. Let's get rid of pi. Come on, pi. Let's go. Let's bring up my calculator, and we want to go to say the trig. So the inverse sine, please, if you will, of 15 divided by 25. Close the brackets, hit enter, and we get 36.89 blah blah blah, but it says to the nearest degree, so let's write that as 37 degrees. The diagram below shows a cargo ship next to a port. The base of the crane is shown at point Q. The base of the crane is 20, yep, from a shipping container. Crane rotates 20 degrees. What is the distance RP? So there we go. So this is basically looking for that distance, which is the cosine rule. And because we know that with the cosine rule, a squared equals b squared plus c squared minus 2bc times by the cosine of the included angle. So we know that rp squared would be equal to 20 squared plus 38 squared minus 2 times 20 times 38 times the cosine of 120 degrees, which, believe it or not, when I put all of that into my calculator, and I've done all that hard work already, gave me rp was equal to 51 meters. And remember, it had to be to the nearest meter. Now, the shipping container is a rectangular prism. 4 chains connect the shipping container to a hoist at point M. So here is my hoist at point M, as shown in the diagram below. The shipping container has a height of 2.6, it has a width of 2.4, and it has a length of 6 meters. And each chain on the hoist is 4.4 meters long. Okay, thank you very much. What is the vertical distance in meters between point M and the top of the shipping container? So it wants me to come down to here. So I'm now going to draw a line between there and there because I know that's a right angle triangle. How's that going to help me? Well, if I now look at a plan view of the shipping container, there is my center point here. And I know that that's 6, and I know that that's 2.4. So can I find this center point here, and more importantly, that distance there? Because if I know that distance, then I know this distance, and I've got everything I need to help me find this value here. Let's call it h, sensibly for height. Let's make it look a little bit more h. Okay, well, I can do that because what I've got here, I've got a bit of Pythagoras theorem. So we're going to find this value of x here. So we know that x squared is equal to 6 squared plus 2.4 squared. And using my calculation, I ended up that that value there was roughly 6.462. That's the total length. That's that total length there. All right, but what I actually want is half of that length to give me my other triangle. So here's my now triangle. This is my point M. This is H. I know that this is 4.4. And this works out to be, roughly speaking, 3.23 dot, 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 dot. So once again, I can now say that H squared is equal to 4.4 squared minus 3.23 dot, 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 all squared. Now again, you've got a CAS calculator. Hopefully you did not round that to decimal points there. You can just use whatever your values in your calculator. And that gave me a value of H rounded to the nearest meter of 3 meters. Okay, so starting Graphs and Relations Module 4, this is the last module, and it says the graph below shows the membership numbers of the Wombetong Rural Women's Association for each of the years 2008 to 2018. First question, hopefully nice and simple, just to sort of ease me in. How many members were there in 2009? Well, there was 2009. That's a beautiful value. It's right there on a cross point. So I'm just going to write down that there were 60 members. I'm going to write that slightly better. There are 60 members. Fabulous. Show that the average rate of change of membership numbers. So the average rate of change of membership numbers means it wanted me to take the two membership numbers away from each other and divide by the time that that change took place in. So what did we want? 2013, which is here, and 2018, which is here. Now, there is a trick in the sense of the scale. Each of these little marks is worth 2 members, so don't get tricked. So the first thing is, let's say 2013 to 2018. So 2018 worked out to be 32. This value here was 62. And I'm going to divide that by my number of years, which is 13, 14, 15, 16, 17, 18, which is 5. So that gives me minus 30 divided by 5, which just happens to be minus 6. So realistically speaking, what I need to do now is say, well, therefore, the average rate of change is equal to 32 minus 62 on 5, which gave me minus 6. Job done. If the change in membership numbers continues at this rate, how many members will there be in 2021? Well, we know there are 32 members in 2018, 19, 20, 21. So we've got to lose another 3 lots of 6, which is 32 minus 18, which gives me the wonderful value of 14 members will be left. I believe that says how many members will there be? Yeah, 14 members left. Each branch within the association pays an annual fee based on the number of members it has. To encourage each branch to find new members, 2 new annual fee systems have been proposed. Proposal 1 is shown in the graph below, where the proposed annual fee per member in dollars is displayed, with the branches up to 25 members. What is the smallest number of members a branch may have? Well, basically, it seems that that is where it starts. Reading that value off gives me that the smallest number of members would be 3. The incomplete inequality below shows the number of members required for an annual fee per member for $10. Okay, so here's my $10 line. Complete the inequality by writing the appropriate symbol and number in the box provided. 3 is less than or equal to. Now we know it's less than or equal to because that's a coloured in dot. The number of members, which is, well, we have another coloured in dot here, less than or equal to, and how many members were there? There were 10. Proposal 2 is modelled by the following equation. Annual fee per member equals blah, 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 blah. So there we go. That's a nice little formula for me. Okay, so sketch this equation on the graph for proposal 1 shown below. Now, I'm not overly sure if this is a trick question, to be perfectly honest with you. It said we had the minimum number of members had to be 3. So I don't know whether this graph, and I haven't drawn it actually too, but what I'm going to do is I've already worked out that I know that that value there is a value, I know that this value here is a value, and that value there is value. Now I am no way going to be able to work this out and make this a straight line, although not bad. But there we go. You should have drawn on something very, very similar to that. How would you have worked it out? My advice would have been, well, I would have got 10. So I would have said, well, let's work out what my annual fee per member is when I had 10 members. Put 10 in here, multiply it by minus 0.25, add on 12.25, do a kiss. Likewise, I would have chosen 15, maybe 20, maybe 25. I'd have chosen a few values in there, put it into that equation and plotted my graph. How did I know these were some of the values? Because the question then went on to say, write down all the values of the number of members for which this is the case, i.e. where there is the same annual fee. So there was one there, and in fact there was one there as well. Now, when I originally did this by drawing my graph, and I'll write this down now, it was 9, 17, and 25. When I originally did this, my graph actually went through 8, 16, and 25. All right, so just to confirm, it went through 8, 16, and 25. And I was like, I'm not sure that's correct. So what I did, just to make sure, was I put 8 back into my equation up here. And when it didn't give me the same membership, when it did not give me $10, I realized that my graph wasn't accurate. So I went back and said, well, maybe it's 9. Put 9 in there, out came 10. Likewise for this 17, I put 16 in and found that in fact didn't come out with the right value. So it was just a little thing there to just to check. Okay, so for question number 3, the last question in this particular exam. Let X be the number of cars used to travel, thank you very much. Let Y be the number of minibuses. Constraints are given, inequalities 1, 2, and 3. Each car can carry a total of 5 people and carry a total of 10 people for minibuses, all right? And a maximum of 60 people. So I now know that I can write this inequality as 5x plus 10y is less than or equal to 60. The graph below shows the 4 lines representing inequalities 1 to 4, also shown on the graph of 4 of the integer points, which satisfy those inequalities. Each of the integer points is marked with a cross X. On the graph above, marked clearly with a circle, the remaining integer points. Now, what I did was I went back to my inequalities and realized, so I tend to shade these to make sure I know what I'm doing. So I shaded here, I shaded here, I shaded here, and I shaded here. So I knew that my points had to fall within there somewhere, and so all of my points were then circles where actually there were specific integer values. And so there is my integer values. Each car will cost $70 to hire and each minibus will cost $100 to hire. What is the cost for 60 members to travel to the conference? Well, we know that this line here stands for 60 members. And so we are looking at the cost for that 1 point there, right? So we know that 60 members will actually, inside that objective function, give me, or inside that feasible region, will give me 4 x's. So I want 4 cars, which is $70, and I want 4 minibuses, which are $100 each, which gives me a staggering total of $680. What is the minimum cost for 55 members to travel to the conference? Again, I'm trying to find out which of these circles stood for 55 members. And for those of you who are very excited about this type of stuff, it actually worked out to be that dot there. That stood for 55 members. So that's 5 cars and 3 minibuses. So 5 cars, 5 times 70 plus 3 times 100 gave me $650. And this final part of the question, just before the cars were booked, the cost of hiring each car increased. The cost of hiring each minibus remains as $100, okay, and all original constraints apply. Now, this was the tricky part of the question. If the increase in the cost of hiring each car is more than K dollars, then the maximum cost of transporting members to this conference can only occur when using 6 cars and 2 minibuses. So if we go back to our diagram and zoom in just a little bit, what it's trying to say is this point here, at a certain gradient of our cost function, and let's say we have an objective function of something ax plus by, then at certain points, the gradient of this line will mean that by the time, if you think about the sliding, sliding point, or the sliding line, that's the only point that it's going to get to, all right? And it doesn't want that. What it's saying is, what value of k will effectively not make that happen. So what we're going to try and do is, rubbing this a little bit out, is look for a line that is actually going to be parallel to this line here. Now I suppose the important point there is that the gradient of that line, because it's the line x plus y equals 8, the gradient of that line is equal to 1, or in fact minus 1 actually. So we're going to try and keep this here to have a gradient of minus 1. So zooming back in just a little bit, let's go back to this bit here. So we know that the cost of hiring the minibus is 100. So we've got some function p equals ax plus by, which is, what is the value of b? 100y. So we're trying to keep the gradient of this equal to minus 1, which actually suggests that the value of a and that value of 100 would have to be the same. So in this situation, a would have to be 100 for it to be on that line. Now that means that the cost therefore of the car can be no more than $100, suggesting that the value of k would have to be 30. And ladies and gentlemen, we are done. We have reached the end of this paper. Fingers crossed, all is good. One of those questions, I'm not overly happy about that last one there for the networks. But otherwise, fingers crossed, all is good. If you think there's anything wrong, let me know in a comment below. If you haven't already done so, subscribe to my YouTube channel. It is tiny, and I would love some more subscribers. Even if you turn off the notifications, it's nice to know that people have watched. Or mathsguru.com. I'm done. I look forward to seeing you in another video. Math Methods is on Wednesday, so fingers crossed I'll have the answers to that Wednesday night. All right, take care. See you again. Bye-bye.